Hello all, welcome to our Iceland Technologies YouTube channel. Today we're gonna see about skin prick test wheel detection in 3D image through convolution neural network. Skin prick is nothing but it's a common test. It's a diagnostic procedure used to identify allergies. It works like a small amount of allergic extracts from the skin, usually on upper forearm or back. This is done by making tiny punctures or pricks in skin with needle or a lancet that has been dipped in allergies. This reaction can be the test is designed to provoke a localized allergic reaction if the person is allergic to any of the test substance. A red a tipsy bump or a wheel at the site of break index a positive reaction. Now, skin prick is crucial for diagnosing allergies by measuring the size of wheels. Size of wheels is nothing but the area surrounded the diseased area surrounded by the skin after exposing it to an allergies. Traditional manual measurement methods are flawed due to variability between observes and difficulties in measuring irregular shaped wheels, leading to inconsistent and unreliable results. To overcome this issue, recent advancement using machine medical imaging and machine learning to automate the measurement of wheel size, technique like 3D imaging, principal component analysis, nothing but PCA, and deep learning. Deep learning is we have used UNet are employed to improve accuracy and reduce errors. Standardized protocols promoted by organizations like Global Allergy and Asthma European Network help ensure consistent results. Now, our problem is with the current skin prick test method is that the manual measurement are inconsistent due to variability between observes and difficulties with irregular wheel shapes and skin pigments. Existing automated systems also face challenges such as needing complex adjustment and nothing being universal applicable. There is a need for reliable, standardized, and universal effective automated system to improve the accuracy and consistency of SPT measurements, leading to better allergic diagnosis and research results. Here, now we will see our workflow. Yeah, this is our workflow. First of all, our data, I will show you our data set. Yeah, this is our data set. We have collected it from Google. This is all based on one diseases. This is all skin prick diseases. You can go through this. Yeah, this is one of the type of diseases. These are all one diseases. In each folder, it contains of about 50 images. Now I'll show you a workflow so that you can understand very well. Now this is our collected data set. Pre-processing nothing but we will reshape our height and width of every image to view into our neural networks, and then for training data set. After the training data set will get into CNN algorithm. Here we will extract the features among the images, and we will train those images with the labels. And finally, we will predict the skin prick whether what image is named as a disease name, and you will see further. Yeah, I will show you now the training code. Yeah, this is our training code. Yeah, this path is our dataset path, and these are the classes, total 9 classes. That's what I mentioned it here. Now, in this function, we will load our data set, and here we will separate our train files and testing files for further process. And in this phase, we will take our label name extract by the list here. And then here we will do a pre-processing things like path to tensor. What we will do is we will take our 3D dimension of every image and we will convert it into 4D tensors. Because of we will due to our training, in spite we were taking 4D tensors. Here, this is nothing but it's a graph of our training images, and this is our model. This is our CNN model here. First of all, I'm giving 32 filters. It will extract 32 filters for of every image. After that, it will go for 64 filters. And then finally, your model will be compiled with categorical laws, and your model will fit into your data set here. And then your model will be stored outside as trained model DNN.h5. Yeah, you can see this. This is our train model. After this, in testing part, we could dump our model into our testing part. This is our training code. I will show you where our model is imported. Yeah, can you see this? This is our train model. Based on this model, we could detect the skin disease of the required image, of the given image. Yeah, this is nothing but this is a GUI of a front page, and the front title is window with background image. I will run this code so that you could get a good idea. I'll run this one. This is our first window. This window I have written here. Like you can see this. Th- This is our login window. I have mentioned. This is our login window. This came here. Here we could view our ID and password for security purpose. Login. Now this is our second GUI. This is the main GUI. Here we want to import our image, trained image. Yeah, this is our data set, and I want to import any one of the image in this. Yeah, the predicted image is vascular lesion, and this is a precaution to prevent complications from vascular lesion. Maintain a healthy lifestyle with a regular exercise and a balanced diet. And promptly seek medical attention for any change in size, color, or symptoms of vision. Yeah. Now I'll show you another one. Yeah. Now you can see this very clearly. What our trained image have given clear thing. That's this the predicted in this melanoma, and this is a precaution. A precaution for melanoma is regularly check your skin for any new or changing moles or spots, and seek prompt medical attention for any suspicious changes. Always wear skin care with high SPF, protective clothing, and seek shade during peaks and hours to reduce UV exposure. Yeah. Thank you for watching our iListen Technologies YouTube channel. Like and subscribe and follow our iListen Technologies YouTube channel. For more, follow our iListen Technologies YouTube channel. Thank you.